Right, a couple of weeks ago we had a session on cryptocurrencies and blockchain. It was a sort of show and tell session, so people stood up or sat down and told us what we've been up to. In general terms, I think there were about, let's say, 40, 50 people there, and in general terms there seemed to be about half of the audience who didn't know much, had heard a lot about blockchain and cryptocurrencies, didn't really know much about it. They're complete beginners. There seemed to be then about a quarter of the audience who'd bought cryptocurrencies mainly speculatively. There were no people who'd ever bought anything real with a cryptocurrency, which is interesting. And then probably about a quarter of the group who'd done some real stuff, like mining and set up their own wallet and a whole host of stuff around cryptocurrencies. So it was clear to me that there are some people who need to start with the basics, and I'm aware that some of you know all this stuff, so you might want to, go. But I'm going to basically start with I'm just going to run through a number of what I think are good YouTube videos which talk through the basic concepts, because I think, if you're going to talk about blockchain, you really do need to understand the basic concept of what a blockchain is. So this is a very good visual demonstration of the blockchain. It goes through the whole thing, and by the end of it you'll go, oh right, I get it now. There's a presentation on sort of the future of, or potentially the future of Bitcoin, so the internet of money, which is quite good, I think. There are a couple of presentation videos on the differences between various cryptocurrencies, which I think are good. And then there's one here on the business uses of blockchain, of which there are many and various. So, I think this is a good set of videos to go through. So the plan is just to effectively go through these, stop at the end of each one, have a discussion, make sure people have got the basic gist of it, and then move on. So if you've seen it before, if you already know it, I'm quite happy for people to go if you already know it, but I thought we'd start with the basics to get a sort of common level of understanding. Is that okay? Good. Right, let's go for it then.
This is a blockchain demo. We're going to do this in a very visual way, though. We're going to make it very easy to understand by stepping through the key pieces of what a blockchain is in a visual way. But before we get started, we need to take a look at this thing that we call a SHA-256 hash. Okay, and a hash, this is one of them right here. Hash looks like a bunch of random numbers. And essentially what it is, it's a fingerprint of some digital data. And it just so happens it's a fingerprint of whatever I type in this box. So if I type my name, Anders, into this box, you see that the hash has changed. As a matter of fact, it changed every time I typed a letter, right? So I'm going to go back to this. So it says Anders. Okay, so this is the hash of the name Anders, all lowercase. It starts with 19EA, right? Okay, so if I delete that, and I go again to Anders again, you can see it starts with 19EA, the same exact hash. In that sense, it's a digital fingerprint of this data. Whatever data is here, every time you type exactly the same data, you get exactly the same hash. And I can type anything I want. So you can have nothing, like this, E3B0, that's the hash of nothing. Or you could type tons and tons of stuff. As a matter of fact, you could put like the Library of Congress in here, and you would get a hash. And the interesting thing about it is, regardless of if there's a tiny amount of information, no information, or the entire Library of Congress, you're always going to get a hash that is this long, this many characters. So you're not going to be able to pre-guess what this is. You kind of have to put the Library of Congress in here to figure out what the hash is, but you'll always get exactly the same hash regardless of how many times you put exactly the same information in. So what I'm going to do is extend this idea of a hash into something that we're going to call a block. All right, so let's take a look at a block. So this is a block. And it's exactly like the hash, it's just that that data section I've broken out now into 3 sections. One called block, this is just some kind of a number, this is block number 1. A nonce, which is just yet another number, we'll go into what that is in a second. And then just some more data, just very similarly to the way we had it before. However, the hash of this, which includes all of this information up here, is down here, and it begins with 4 zeros. You see that? That's a relatively unusual hash. You know, most of them are not really going to start with 4 zeros like that, but this one happens to. And because it does, totally arbitrarily, I'm going to say that this block is signed. Okay? So what would happen if I were to change any one piece of this information? Let's say if I were to type something here, right? The hash is going to change. And what's the chance of that if I type letters, this hash is going to start with 4 zeros? Pretty low. It's probably not, right? So let's see what happens when I do that. I'm just going to say hi. Now look at that. Right? This hash does not start with 4 zeros. And so the big background here is turned red. So now you know that this block with this information in it is not a valid or a signed block. Okay, and that's where this nonce comes in. This nonce is just a number that you can set to try to find a number that fits so that this hash starts with 4 zeros again. Right, so how do we do that? Well, let's start with 1. Does that start with, no, it's 3, 2, 7, that's not 1. So let's try 2, FF now, 3, 4, 5, 6. You get the idea, like I could sit here, there's one that starts with 0. I could sit here all day typing these numbers and trying to figure out one that actually is going to hash out to something that starts with 4 zeros. It's going to take a long time. So here I have my little mine button. I'm sure you've been wondering what happens if I press that. So what's going to happen when I press this mine button is it's going to run through all of the numbers from 1 all the way up to try to find one where the hash starts with 4 zeros. And this process is called mining. Let's do it right now. Now it's checking all of the numbers from 1 all the way up there. Now it's stopped at 59,396, and that one just happens to hash out to something that starts with 4 zeros, and it satisfies my little definition of what a signed block is. Okay, so that's a block. Now, can you tell me what a blockchain is? It's probably just a chain of these blocks. Well, how do you put them together? Let's do that. All right, so here's my blockchain. I have block number 1. It has some kind of a nonce just like before. There's some data area to it, but then it has this previous. Here it's a bunch of zeros. Let's roll forward. So this is block 2 and block 3 and 4. This blockchain has 5 blocks on it, right? The previous here starts with 00, AE8, right? Is this number, AE8. And then this previous, B90 is this one over here, B90. So you can see that each block points backwards to the one before it. You remember that the first block over here, there actually is no previous, so it's just a bunch of zeros. It's actually just a fake number. Okay, so just like we did before, what happens if I change some information here? Right? It's going to change the hash of this block, and it's going to invalidate it, right? Well, let's try that. So I'm going to type pi again, and sure enough, that block is invalid. All right, just as we assumed. But what would happen, I'm going to fix that now, we'll go back to something that worked. What would happen if I change something in this block? Right, it's going to change this hash, but this hash gets copied up to this previous, so it's going to change this one too, right? So it should break both blocks. So let me try typing hi in there, and sure enough, right? So we can go back as far as we want, to some point in the past and break that block, and it'll break all the blocks since then. Everything before is still green, but this one is red. So if I wanted to, change something in this blockchain, I could just go over to block number 5 right here. We could change it. I'll put hi. and then we could remine it, and pick a different nonce. We'll do that right now, and we could essentially alter the chain. So we've done it, so we should be good now, right? All right, well, what happens if I go back in time to here and I break it here? Now I have to mine this block, which will pick a nonce that makes this block hash out to 4 zeros, if we can find one. Sometimes it takes a while because it's got to run through a lot of them. There it is. It found one at 138,000. All right, but this one is still broken because although this one starts with 4 zeros, adding the 4 zeros with different stuff up here still makes this block hash out incorrectly. So I also have to mine this block. All right? And that takes some amount of time. That one was a little bit quicker. And then I have to mine this block to fix it. All right, so what we're showing here is that if I go and change this last block, all I have to do is remine this block. If I go way back in time to back here and I make a change like that, I'm going to have to mine this one, this one, this one, and this one. So the more blocks that go by, the more blocks in the past that we are, the harder and harder and harder it is to make a change. And so that's how a blockchain is going to resist mutation, resist change. Okay, so now, I did, if I do this in this block here, you can see that I've changed it to high and I remined it, blah blah blah. How would I know that my blockchain has been remined? All right, let's take a look at that. I'm going to hit this little distributed thing. So now we have a distributed blockchain. It looks exactly like the last blockchain, okay, up to 5. But this is peer A, the first peer. If we go down here, you can see here's peer B, and it happens to have an exact copy of the blockchain. There's actually also a peer C down here, right? And this could go on forever. There's many, many peers out on the internet, and they all have a complete copy of the blockchain. So in this case, if I look at this hash, it's 00E4B, right? If I go down to this one, I notice it also has E4B. If I go down to this last one, it has E4B, so they must be identical. And I'm going to demonstrate that by going here and typing something, type hi again, and then I will remine this block. And I've got some other number, now let's put some other number up here. So I should be able to mine this block. Okay, now all the chains are green, right? They're all green. However, this chain says the last hash is E4B. The bottom one says that too, E4B. And this middle one here says 4CAE. So I know just by glancing at this one little hash that something is wrong in this blockchain, even though all of the hashes start with 4 zeros. I know that this one is different. And it's different because I have 2. It's essentially 2 against 1. We're a little democracy here, right? This guy argues that it's E4B. This guy argues that it's 4CA. And this one is E4B. So E4B wins. So that's how a completely distributed copy, having a copy on many different computers, they can all very quickly see if all of the blocks are identical. And remember, blockchains can have 400,000 or 500,000 blocks very easily. So rather than checking through all of them, all you really have to do is look at the hash of the most recent one, and you can see that if anything in the past, anything way back here was altered, you can tell by looking at this at the last block in this in the chain. It's going to hash out to something that doesn't start with 4 zeros and looks very different from what the hashes on the good chains are. Okay, so that's a blockchain. That's the entire thing. There is no more to it than that. But it's kind of not really useful because we don't have something in this data area that means anything. I keep typing my name or hi, and that's sort of irrelevant information. So what we really want is a token. So let's do a token on our blockchain. All right, now look at this. So I have this token just totally arbitrarily, I'm calling these, I guess, dollars. Right? So we have $25 from Darcy to Bingley, $4.27 go from Elizabeth to Jane. You get the idea. It's basically there's all these transactions that are happening. And just replace the data with these transactions. And just like we saw before, so there's multiple blocks here. This one has more transactions. It doesn't matter how many transactions there are. There can be many, or there can be few, or none. If we keep going forward here, just like we saw before, if we go down, we notice we have all these other copies of the same blockchain, right? So now here's where the immutability is important. If I change something back here, you'll notice that this is, A7FC, blah, blah, blah. It's something else. So it's something different than what's down here. So in this way, I mean, it's very important that if I were to go back in time and change some value that we would notice. It's very important with money that you don't lose track, and that's the whole point of using a blockchain here. This is the whole point of resisting any kind of modifications, of things that have happened in the past. So that's the reasoning behind using a blockchain to remember tokens. Now, one thing I would mention here is that we're not listing, Darcy has $100 and he's giving 25 of it to Bingley. The only thing we're saying is Darcy gives 25 to Bingley. We're not remembering a bank account balance. We're only remembering money movements. So this begs the question, does Darcy have $25? Well, we have a problem here in this version of the blockchain. We don't actually know if Darcy has $25. So let's look at a Coinbase transaction. So if we look back here at Coinbase, we're going to add a Coinbase transaction to our blocks. And this is very similar to what we've seen before, but we're just adding a Coinbase at the top. And what that's saying is we're going to invent $100 out of thin air and give it to Anders. And there's no transactions in this block because nobody had any money previous to this. In the next block, another $100 comes out of nowhere and goes to Anders. I'm a fan. I love it, right? I'll take $100. Now we have some transactions. You can see that they're all from Anders. They're all from me because I'm the only one who has any money at this point. So I'm sending 10 of my dollars to Sophie. Do I have $10? Yeah, I do. I look back and I see that this Coinbase transaction has given me 100, so I have at least 10 and I can send it on. And you add all these up and they don't go over 100, and it follows sort of a basic rule of a currency. Like you can't invent it out of thin air. You can't create money out of thin air. Its dispersion is controlled. So now if we look at this blockchain that we've created and we zip forward in time and we notice that we see that Jackson is giving Alexa $2. And so does Jackson actually have $2 to give Alexa? Well, we go back to the block before and we see that Emily, who had gotten $10 from Anders, gave 10 to Jackson. And so Jackson does have the money. So we can just go backwards and find that out. And that's actually one of the benefits of having a previous here. It's easy to go backwards. We just look for the block that looks like that has that hash, and here it is right here. Right? So it points to blocks back in time and allows us to trace the provenance of any coin that we want. So that's a basic blockchain, and we're running a currency on top of it. And as you know, blockchains there are many copies. Everybody has a copy of it. So if we mutate, this and make it $6, these go invalid. It does not agree with these blockchains down here. These copies of the same blockchain down here. So this resists tampering, which is what you want for a currency. It works very well for things that are small and transactional, like this. Go ahead and fix that. And they're just a very efficient way to handle agreement on what has happened in the past. It's kind of this immutable history that goes down with time. So that's a basic blockchain and a token on it. We're glossing over some main points, but if you dig into the demo and click through these things and play around with it, you get a better and better idea of how this works. There will be a part 2 where we go into a little bit more detail about how the transactions are created. Till then, this is a
straightforward? No?
I know more now than I did when I came in here, so yeah.
And the distributed one requires something over the top of those individual nodes that are running it. A blockchain.
Well, the nodes each have a copy of the blockchain. Is that
something that yes, because you didn't really explain what happens in instances when he does tamper with it. They have a different version to everybody else.
Yeah.
What happens? Some broker sort of looks across all of them and says you're out of line, fix it.
Yes. Yeah. So the basic concept though of store some data, use a hash value to effectively sign that data, have blocks of it which you connect together, which, if you ever want to change something, it's really difficult to go back and change it. That change shows up effectively. And having distributed copies of that blockchain, effectively say, change can be identified and stopped effectively, because that's essentially what the whole purpose of it is to make that history of currency transactions non-changeable. That's the whole idea effectively. So it makes it traceable. You know who's got what. You know that it can't be tampered with, because if it is tampered with, all those numbers mismatch. That's the basic idea of a blockchain.
Is there an agreed minimum number of copies?
So all the different cryptocurrencies have different blockchain equivalent implementations, and so for a particular ledger like that and a particular currency, then the rules are relatively clear, but they're not all the same.
So that would use, so this is, yes, the underlying technology, but I'm assuming then that would dictate effectively how many coins were in distribution. Because is it a finite or is it an infinite length?
So for example, Bitcoin on blockchain has rules about how often those pages, those blocks are created. So effectively, it's 10 minutes, isn't it? Every 10 minutes, a new block gets created and signed. Effectively, if there's 10 transactions in it or 10 million transactions in it, it doesn't really matter. But effectively, that's an example of a blockchain where they've got rules that say we want to make sure that every 10 minutes we generate a new one. So something that happened 60 minutes ago, is 6 blocks away, and therefore the chances of anybody fiddling the data that we generated an hour ago is nigh on, well, computationally very difficult.
It starts to get quite interesting on the economics of that, don't they? So
it does.
Different currencies have different rules as to whether there's a fixed amount of coins or not.
Correct.
So Bitcoin, for example, there is a theoretical maximum of coins will be on each node. The amount of coins you get from mining each block reduces every time.
Okay.
But then the economics guys can really start talking about what happens if you have currency.
And I think we've got some videos on that later. But what we talked about last time was this idea of a blockchain. I think there are a lot of people that didn't really understand the concept. So, I mean, it's worth watching that a couple of times. But fundamentally, it, to me, sort of describes the idea of you put some data in a block, you sign that block, you create a new block, that chain together, and fundamentally, you're trying to stop change in each of the previous blocks.
So how does a blockchain get created? Because it's talked about
a blockchain.
Have a blockchain.
Yeah, a blockchain gets created as people So if you buy a Bitcoin, so blockchain's a technology. There are lots of uses of blockchain, which we'll go into later. So, for example, some people are using them to trace diamonds, right? Diamond gets dug up, it gets polished and sold once, then it gets passed on to somebody else. So you want to understand the authenticity of that particular individual diamond. Or cattle. You want to know where a cattle was born, where it was transported to, where it was slaughtered, where it was sold. So effectively you've got a chain.
One
and
thing
you
is
want to trace
It's
it.
your ledger,
Yeah.
isn't it?
But what's stopping you from creating a new ledger that maybe not?
So there's nothing stopping you, which is why there are thousands of cryptocurrencies. But will people use your blockchain? I suppose you've got to give them some incentive to do so. So in those blockchains that you saw there, you have to have this idea of mining, right? And in Bitcoin, mining is the sequence of guessing that number. It's a much more complicated number, but it's basically the same idea as he was doing. And so what happens is, you could go onto, I don't know, eBay, Alibaba, probably somewhere in China, you could buy yourself a £2,000 computer and do Bitcoin mining, right? You could set it up at home now, plug it in, and it would spend all its day calculating those numbers, as that guy did, right? If you get that number right, you get a bit of a Bitcoin as payment for calculating those numbers. And that's effectively what there are. I think there are probably a couple of people in the audience who have done Bitcoin mining. That's effectively what's involved in it.
So it's guessing the nonce that signs the block.
The cover block.
And once you've found it, the one person in the world who finds that right nonce signs the block, gets a bit of a Bitcoin, and then everybody's on to trying to solve the next block.
Yeah, exactly that.
Okay.
Is there one, so take Bitcoin, is there one blockchain for Bitcoin, obviously with numerous blocks being created?
I think so, yes. Yes, I think there is. And then someone, for example, spawned the code and produced something called Bitcoin Cash, which has the same basic idea of the blockchain, but some of the rules have changed. And so people have tried many mechanisms to effectively implement a sort of, I'm going to use the word distributed ledger like the one, but some of them aren't even distributed, but that idea of a non-changeable record of what's gone on. And that's the basic idea. That makes sense?
The interesting bit I found on the non-changeable record is there's a relationship between the amount of currency that's in circulation and the number of users you have to have mining the next block for the thing to be a feasible currency. So blockchain, for example, has there's a lot of money in blockchain, but for it to work, you've got to have millions and millions of people with expensive graphic cards mining.
Yes, you have.
Otherwise, the whole thing falls apart. If you only have a small number of people mining, then it's possible for a malicious person to buy a big mining rig.
Yeah, and take over the whole thing.
Blocks.
Yeah, correct.
So if you're a small currency, you'll have a small number of people mining.
Yeah, and therefore people could take over.
That currency. That's the real limit to somebody else starting a brand new blockchain.
Good. So are there any people now in the audience that don't get the basic idea? So the basic idea of blockchain is to create a non-changeable record of events. They might be currency events, they might be cattle movements, they might be a whole host of things. And later on we'll look at the sorts of business type problems that are applicable to blockchain. But the basic idea is you create blocks of data, you sign them, you chain them together, you have multiple copies of them, and using that mechanism you can tell whether something has been changed or not. But what you're trying to do is stop change. You basically want a record of what went on, you never want anybody to change it.
So I mean, there's two stages to the sealing of a block. You decided 10 minutes is up and that's
Yeah,
going to be
so
sealed.
10 minutes, we've had a million transactions there all in the
Then
block.
all the people who are mining it, they let loose on it, and then they've all got it, so you can't change it then, because that would mean if somebody hacked it and changed it then, they're all mining the wrong
Yeah.
thing and it wouldn't work.
Yeah.
And then when somebody gets the actual nonce,
Yeah.
causes the 0000,
Yeah.
then he stops, and then that's the second phase of being
Correct.
locked.
Yeah, that's correct.
So how do you stop the person who's found the correct nonce from changing?
I think the software that you use does that, I believe. Is that right? Who's done that? So when if you're part of a pool that's doing mining, and you say, I've got this rig, because quite often people join together into groups effectively to do mining. So they buy a £2,000 worth of kit from China, they plug it in, it's full of graphics cards, it costs them 100 quid a week on electricity, and they hope that they get some bitcoins, is basically how it works. So if you add your rig to a pool, a group of people now effectively all mining, it's the software that you run that effectively says, we're trying to solve it, oh, someone solved it, we'll get on to the next one.
I'm assuming there's a verification step in there that say, I mean, okay, if you want it to be malicious, I suppose if you've got you get the block that you're wanting to sign and I'm about to go and mine it, I'll stick a transaction in the bottom of there that says pay me £1 million.
Yeah, absolutely.
Now I'm going to mine that as fast as I bloody well can until I get the nonce. I've got the nonce, fantastic, it's signed.
But there must be there's a number of people that have to get
validate. Validate the nonce.
Apart from the transaction, we didn't see in that video. That video just said pay X from Bob to Sid.
Yeah.
When you do the real one on the real crypto codes, you also have to use public key cryptography to say, hey, I sign with my private key.
Yeah.
The transaction that says, pay money from that previous output to that public key.
Right, okay.
So if I don't have so in your example, you wouldn't have
I wouldn't have
£1 million
keys.
coming in from it.
Yeah, okay.
You could create a fake one, but when the miner receives your transaction, it will say, this says I'm paying from block 52, transaction 17, output 4. That doesn't exist. Or that key doesn't, the public key on that doesn't match the signature you supplied, so it chucks
out.
So that was quite simplistic. There's more to it than that. I wanted to get the basic idea across.
Quite hard to attack a blockchain.
But also, as soon
The
as
size of the economy, so many people mining.
the
The best way to make money out of it is to sell someone a brand new cryptocurrency, which happens quite a lot.
It's a bit of a gamble on hope, though. You're putting processing effort into the hope that you're going to genuinely
Absolutely.
buy something.
Absolutely, you are. Yeah, but most people do that because they believe Bitcoin will go up in value, which, if I look on Coinbase, mine are probably flat and down. So. Right. So what we're going to do now is go through this guy. He's written lots of books, lots of articles, loads of stuff on this area. This is more a sort of general view of cryptocurrencies and blockchain. So hopefully when he starts using the words blockchain, you'll understand what he's talking about. But this is quite a sort of, I think, quite a good explanation of where things are going and the sorts of considerations people are making.
So who invented the concept of the chain, the distributed ledger part of it?
Well, that's a very good question.
There
There is an anonymous person who invented it or wrote it down effectively, but no one really knows who that was. So he does have there is a name associated with the written down information, but nobody really knows
who
the person was.
Someone's invented Bitcoin and the concept of the distributed ledger. The output of that is the use of the distributed ledger for other business applications that require that non-repudiation.
No, I think if you read the original paper, it was focused on the idea of currencies, from what I've only skimmed it.
His idea was to exchange of information about a bank.
Yeah. And then other people have got this idea of, oh, well, if you've got this immutable, non-changeable, distributed ledger. It's probably not a ledger at that point, but source of information. Then you could use it for lots of things. And it's the business applications of blockchain that then quite interesting, and people are talking about.
His newest book just came out 8 days ago, called The Internet of Money, which is a master history. Please welcome Andreas Ontavos.
Yeah.
Good morning, everyone. Let's start with a quick poll here. How many of you have used a digital currency like Bitcoin at least once? And how many of you own Bitcoin at this moment, or any other digital currency? Okay, we can fix that. If you like, later on today, come find me. I would be delighted to demonstrate to you how to set up a Bitcoin wallet on your smartphone. And I will give you your first fraction of a Bitcoin, not a whole Bitcoin, and show you how a transaction works. Because Bitcoin and the digital currency revolution it has started is best demonstrated and experienced than explained. It's actually very difficult to explain Bitcoin. I've spent the last 5 years learning how to explain Bitcoin. That is my full-time job. Unfortunately, the developers keep making new stuff, which I then have to explain all over again. So, for a moment, forget everything you think you know about Bitcoin. Forget everything you've heard about blockchain, and let's start from basics. In 2011, I heard about Bitcoin for the first time, and my reaction was exactly the same as the reaction of everybody else who heard about Bitcoin the first time, including its founder, and that reaction was, ha! Nerd money. That's probably just for gambling. 6 months later, I heard about Bitcoin again. And this time, I read the white paper that launched this system. And my background in computer science and distributed systems allowed me to see behind the illusion of what I thought Bitcoin was, and it blew my mind. In my life, I have now had 6 occasions in which I have become absolutely obsessed with a system of technology to the point of forgetting to eat, forgetting to sleep, and consuming as much knowledge as I possibly can. My first computer, when I was 10 years old, my first programming language experience, my first modem, my first access to the web, the first time I used the web browser, the first time I downloaded and installed the Linux operating system, and then Bitcoin. When I discovered it, I spent 4 months consuming as much as I could, except food. I lost 26 pounds on the highly inadvisable diet of obsession. I have not emerged from that because I keep finding new layers of depth to understand this. And the reason it's so fascinating is because it isn't what it appears to be at first glance. Bitcoin isn't money. The blockchain isn't a system of currency. It is a platform of trust. It's not a company. It's not a product. It's not a service you sign up for. It's not a currency. Currency is just the first application. It is the concept of decentralization applied to the human communication of value. Because what is money? Inq told us it's an illusion. It's imaginary. reason we don't grasp that is because it's so deeply embedded in our civilization. Money is one of the oldest technologies that humanity has. It precedes writing. How do we know that? The very first samples of writing we have are spreadsheets. They are tallies and ledgers of debts owed, and money pre-existed that writing. You might even speculate that money had an oral tradition until it needed to invent a written tradition, so writing was created for it. In the history of money that now spans tens of thousands of years, there have been maybe 5 major changes. From pure barter exchange to the introduction of the first abstraction of value, shells, feathers, beads, nuts, stones, and then precious metals, and then paper money, and then plastic money, and now network money. Bitcoin introduces a platform on which you can run currency as an application on a network without any central points of control, a system completely decentralized like the internet itself. It is not money for the internet, but the internet of money. And what is money? Money is a language. Money is a linguistic abstraction. Money is a language that we use to communicate value to each other. Money simply allows us to express value, and that value may have economic consequences, but it also has other consequences. We use money to express and create social bonds and relationships and associations and to create organization. Bitcoin is the first system of money that is not controlled by any entity, that is completely decentralized. And what that does is it introduces the very same things that the internet brought to communication. If money is speech, if money is a language, and you disconnect it from all other media, and you make it pure speech, pure content, an internet content type, a protocol designation, money over IP, it completely separates it from all of these previous notions of nations, sovereign issuers, institutions that control. And so we go from institution-based money to network-based money. And of course, everyone will welcome this with open arms. Not a chance. What do you think they said the first time someone was presented with a gold depository certificate instead of a gold coin? They said, that's not money. Go away. What do you think happened in 1950, the first time someone showed up at a motel and presented their Diners Club membership card and said, I'll pay with this piece of paper? That's not money. Go away. And now we're on the verge of a new transformation of money. We're on the verge of creating the first completely global, completely borderless, completely decentralized, and completely open form of money. One where you can build applications because this money is programmable. And you don't need to ask anyone's permission to launch an application any more than you need to ask permission to launch an application on the internet. And the only requirement to have a successful application on the Internet of Money is 2 interested participants. That is your market segment, and you have an application. And 1 million applications will flourish. When you push innovation to the edges of the network, when you remove the requirement for permission, what happens? Exponential explosion in innovation. The applications that could not be built on the old systems of money because they required permission, because they required a significantly large market segment, because they required adoption by many in order to be available at all. Now, none of those requirements exist. Anyone in the world can download an application or use even a feature phone with text messaging and immediately acquire the same powers that institutions of banking have today. And when I say anyone, that's only scratching the surface. Because, ironically enough, not only does Bitcoin and blockchain currency not recognize borders, it also does not recognize people. It doesn't matter if you're a person or a refrigerator, or a self-driving car. Throughout the history of money, ownership of currency required personhood, either as an individual or as an association of individuals in a corporation. Bitcoin can be owned by machines. Bitcoin can be owned by software agents. Machines can pay each other. And that is not just about economic activity. It's the basis for market-based security systems. It's the basis for creating bonds of authentication between devices. It's the basis of new applications that have never been done before. Bitcoin and blockchain technology unifies the systems of money. Today we have systems of money for small payments, systems of money for large payments. We have systems of money for payments between individuals. We have systems of money for payments between companies. We have systems of money for payments between governments. Does that remind you of something? That's how communication used to be before the internet. We had systems of communication for pictures, systems of communication for letters, systems of communication for short distance and long distance, and the internet came and unified all of those. What the Internet of Money does is it creates a single network which can do a microtransaction to a gigatransaction in seconds, anywhere in the world, for any participant without permission. But if you just look at the application of money, you're missing the point. Because you can take the language, the building blocks of this platform, and use them to construct other languages that communicate value. Tokens, reward points, brand loyalty coins. Today there are over 1,000 digital currencies using the design pattern, the recipe of Bitcoin. Most of them are junk. Some of them are not. And over the next decade, we are going to see tens of thousands and then hundreds of thousands of coins. Some will have economic use, some will simply be expressions of loyalty, affiliation. They will represent items in the physical world. The title for a house. The controlling key for a car that can be transferred from one owner to another, and 5 seconds later that owner can step into the car and drive away because the car can validate the new standard of ownership. We cannot yet imagine what applications we're going to build around this. But one of the interesting things we're beginning to observe is that money arises out of the social construct of Homo sapiens spontaneously. It even arises in primates. You can teach monkeys money. You can teach dolphins money. tokens for food.
Yeah. So I'm not going to play. I'll send the links out later. You might want to finish this presentation. But I think it's quite, in terms of what it talks about, it's sort of quite thought-provoking to me. You know, we all sort of sit around talking about digital currencies, but this guy and many like him are basically of the belief that this idea of money and this idea of decentralizing money, much like the internet decentralized a whole host of things, will fundamentally change how people pay each other, will fundamentally change a lot of things. You may or may not believe it, but you know, this guy and many others have a view that this sort of technology is fundamental to.
And then use them to build social relationships. They'll also invent strong-arm robbery.
It's definitely he's quite I think quite thought-provoking in my mind, but it's definitely worth having a listen to the rest of that.
Did anybody see the BBC Panorama program came yesterday?
I saw some comments on it saying what a load of rubbish. Only on Twitter, but I didn't see the program, so I couldn't really put
But
the
in
context.
there they had shown that houses in London have been sold on Bitcoin
Okay.
exclusively.
Oh right, okay, that's quite interesting. I don't know why Twitter. Most people on Twitter were saying what a gross simplification, and
I think
I
they
didn't see the
oversimplified
program.
it. I think the program was only for half an hour.
Right.
So it can't do justice in this kind of
Yeah, but I mean,
But that's true, the black money transfer, lots of people use cryptocurrency to transfer black money across borders.
Yep.
Yeah, my parents think I was involved in some dodgy scam. There was a Panorama program and they saw that it was dodgy. So they were talking to me saying, like, what is it that you're involved in?
Okay. Right, all right, okay.
They're off to their cut.
So last time we also talked about different types of currency. So
Before we go on, where does the bit I'm missing is where's the relationship with the value? So everybody talks around, a Bitcoin is worth $17,000. Where's that set? It's decentralized, but surely
It's just an exchange, isn't it? I'll give you one of these and you give me 5 of those.
But that's an agreed. Everybody knows at any point in time what the worth is.
The market, isn't it?
I might have used you for them now,
Steve.
I don't know what you decide.
So I think in our last session we talked about currencies and the variability of Bitcoin, for example. It is vastly variable and therefore quite difficult to be a real currency. You might. A friend of mine did exactly this. He bought his mining rig from China in Bitcoin Cash, right? They said, we've got some of these rigs on sale. He went, well, there you go, there's some Bitcoin Cash. He missed the first issue because they only had about 1,000 machines, which they sold. And then he was sitting there thinking, oh, have I got one? No, I haven't. A week later, they gave out some more machines, but he'd already purchased, sort of. And basically, he was fortunate because in that week, Bitcoin Cash went up. So actually, 1 week later, when he actually got his goods, they were much cheaper than when he originally bought them. But that variability is quite difficult. And no one really knows why Bitcoin is worth so much, apart from it's limited in number, 21 million. People want it, and therefore, like any economic thing,
so there's something determining how much you can transfer. It's when you want to effectively liquidate it that you can use it to buy stuff and it's got a value.
Yeah.
When you want to liquidate it into another currency, someone is deciding on what. I guess it's the same as any currency. They just decide what they want to pay for it, and you decide whether you want to take what they want to pay for it. That puts it into perspective.
But no one really knows why it's really valuable. There's no real inherent value why it should be really valuable.
You got people selling the mining rigs. I will sell you this mining rig for
£300. Well, all I have to do is plug this into electric and the internet, and it will generate Bitcoin. So why would I trust you to sell me this thing that will make me money when you could just plug the thing in? The whole thing just feels like a scam. And the majority of people making money, I think, people like that fellow who just
And talk about it. Yeah, I agree with that.
Talking about it,
Yeah.
selling presentations on it,
Yeah.
or selling mining rigs. Business case for mining rig doesn't make sense. Why would you sell this thing when you could just plug it in and make more money?
Well, so it might. So my friend who bought one, who ended up with one for say $2,000 ish, sold it for £5,500 in the UK because everybody wants one. So a lot of it's sort of supply and demand, isn't it? So if things are in demand, then you can make money out of it. I think Gold Rush is a very good analogy.
The people who created the fake Gold Rush are now selling shovels.
Yeah. Right, so last time we talked a little bit about different types of coin, cryptocurrencies. So the next couple of presentations just go through some of the key ones. So we talked a little bit about Bitcoin. This, I think, is a comparison of Ether and Bitcoin. And then I've got one on a couple of other currencies, but just because they're not all the same. Some of them are quite different. So it's just worth getting your head around these things. Charities,
You've probably heard of Bitcoin, but what about Ether? There's an arms race going on right now in the world of cryptocurrencies, and Bitcoin and Ether are leading the pack. Ether is a 3-year-old digital currency, Bitcoin's closest competitor, and it's largely been flying under the radar, despite growing at breakneck speed. Investors have been super bullish on Bitcoin because it's nearly tripled in value so far this year. But Ether, it's up roughly 4,000% year to date. These rivals have a lot in common. They're both open source digital currencies used to make somewhat anonymous transactions. Ether even has digital coins just like Bitcoin. They both also saw their share of big vol to lose. The most recent, when Ether virtually lost all its value in a single day in a June flash crash. It went from $319 to 10 cents on one exchange before recovering all of its losses. But here's the critical difference. While they're both powered by a type of technology called blockchain, a whole lot of people think Ether's technology is way better. So what's blockchain? Think of it like the DNA of a digital currency. It's an online ledger that records every single transaction made. Since cryptocurrency has no physical imprint, blockchain allows money to be tracked all over the web so it can't be copied or counterfeited. Ether's blockchain is called Ethereum, and unlike Bitcoin's blockchain, it features a key piece of technology called the smart contract. It doesn't just track transactions, it programs them. We have a touch of this now with automated payments and deposits, but imagine being able to have your money invest, spend, and save all on its own. You'd literally be putting your money to work for you. Smart contracts let you exchange not just money, but property, stock, really anything, without having to go through a lawyer, notary, or some other service provider. It cuts out the middleman entirely. That's why investors have taken notice, and why many think Ethereum is a stronger and potentially more lucrative technology than the one that underpins Bitcoin. It's like the ultimate vending machine. You make a deposit of the cryptocurrency with a specific product you want, and all the mechanics of that transaction are automated, right down to the penalty. You don't hold up your end of the bargain. So whereas Bitcoin is all about payment technology, the Ethereum blockchain technology has other real-world applications, ranging from gambling to banking. That's why a big driver of the Ether rally is its popularity among big corporates. Just take Barclays. It's using Ethereum smart contracts as a way to trade derivatives. Either way, for all the attention that Bitcoin has been getting, it's clear it's no longer alone in the cryptocurrency conversation.
That's very quick, I realise, and quite difficult to catch. But I suppose the point of showing you that is that Ethereum, Ether, is different to just putting transactions into a ledger. They have the idea of being able to put rules into a ledger, essentially. So house purchase is a good example. Effectively today you have to go to a solicitor, and there's effectively a handing over of contracts, a completion. There's a process associated with the transfer of effectively a house. What that sort of technology allows you to do is sort of put those rules into the actual ledger itself. So what that's talking about there is not only getting rid of banks, right, but getting rid of middlemen like solicitors, like lawyers, like organisations that do that sort of middleman, hand it over. You know, I'm a solicitor, he's a solicitor, we are, you know, we've got a legally binding contract, and you know, we're effectively doing this transfer for you. There are a whole host of technologies in this space that are wanting to get rid of that idea as well. Not having to have a human solicitor effectively to effect a sort of legal transfer. They want that building into the ledger. So that's quite interesting.
But if you take the example of purchasing a house,
yeah.
Yes, a solicitor charges you lots of money for letters and paperwork, but they do checks.
So the checks effectively are going to be built into the ledger. So do you own this house? They're effectively envisaging the ability to go to something like buying a house with Ethereum and with Ether, and basically the blockchain effectively doing checks like that. So before you transfer this money to this person and this house to this person, check that they own this. So, you know, it looked back in the blockchain to say, has Rex got £1,000? Well, if you put all house records in a blockchain, and then I want to sell where I live, then effectively a system can go back and say, does Les Frost own 5 Alscott Close? Yes, he does. Therefore, he's allowed to sell it.
It's going to be a few years before it realises that
absolutely.
you live on an X mine, and you need a mining search in order to alert the new purchaser that as you live on top of that.
Absolutely. Absolutely. I agree with all that. Yeah. Agreed.
Always trying to validate is that Les owns that property, and you would do a separate, in that case, Ethereum transaction with a lawyer to go and check there isn't a mine shaft in the back garden.
So it's not going to replace one solicitor, is it?
No, replace the way you pay for your solicitor.
Well, there are people that believe it will eventually be able to do those sorts of checks, depending on, you know.
The company does the mining stuff to have some electronic system that we can communicate.
Correct.
Which was a lot of technology to make this actually be solicitor's transaction. An example you give and others. But
presumably the first time you then use that to sell the house, you've actually done all the surveys of the house. It's there. You do it, you've already got that information.
Okay.
Just saying all these surveys had taken place.
Yeah, so today when you buy a house, they say, have you got an energy efficiency certificate? What if they were in a ledger? Yeah. Today you have to have, I don't know, if you're being a landlord, you have to have a gas safety certificate. What if they were in a ledger? And basically what you're saying is if they're in a ledger and people can't tamper with them, then you have a record that you can trust to check that up. So this is why people are thinking about blockchain and thinking about the applications of it. There are a lot.
Just one other thing about Ethereum. Ethereum is actually a platform on which you can create your own coin. You can make it ERC20 compliant to run on it.
Yeah.
And when you are transferring those particular coins across from one wallet to the other, it uses a bit of, they call it gas, which is nothing but Ethereum as a currency. So you need to have some Ethereum balance in your wallet. And the currency that you're trying to transfer, you will transfer all of it, but it will consume a bit of that gas. So it will use it as
a charge.
A charge.
Yeah. Okay.
So it's kind of like, the way I like to see it, it's kind of like securing stuff, but putting everything in the open where everybody can see it and recognise it for what
Correct.
it is.
Correct. Yeah. So the internet's a good example. There's tons of information on the internet. You don't know whether it's true or not. Right? You surf the internet, you find some information. You have to assess whether it's true.
Yeah.
If you knew it was true, right, by whatever, by this sort of technology, for example, then the whole then you can start to do things that are actually quite interesting. And that's effectively, when that guy said it's a network of trust, that's fundamentally what he means.
Yeah.
He means that you can trust this data. And therefore, if you start putting, birth certificates, matters of record, if you start putting them into a system of trust like that, then people's minds are going, whoa, hang on, that can do an awful lot with that. Whether people will or not, I don't know. But right, the last one. There's a couple others on the list that I'll send out, but this one is more about, if you like, the business applications of.
The blockchain is one of the most promising new technologies for the future. So what is it? It's a distributed ledger technology that underlies cryptocurrencies like Bitcoin and provides a way to record and transfer data that is transparent, safe, auditable, and resistant to outages. The blockchain has the ability to make the organizations that use it transparent, democratic, decentralized, efficient, and secure. The blockchain is likely to disrupt many industries in the coming 5 to 10 years. These are some of the industries it's already disrupting.
Number 1, banking and payments. Some people say that the blockchain will do to banking what the internet did to media. Blockchain technology can be used to give access to financial services to billions of people around the world, including those in third world countries who don't have access to traditional banking. Technologies like Bitcoin allow anyone to send money across borders almost instantly and with very low fees. Abra is a startup that is working on Bitcoin-based remittance services. And many banks like Barclays are also working on adopting blockchain technology to make their business operations faster, more efficient, and secure. Banks are also increasingly investing in blockchain projects and startups. IBM predicts that about 15% of banks will be using the blockchain by the end of 2017.
Number 2, cybersecurity. Although the blockchain ledger is public, the data is verified and encrypted using advanced cryptography. This way, the data is less prone to being hacked or changed without authorization. The blockchain eliminates the need for middlemen, making it more efficient than many legacy systems in cybersecurity.
Number 3, supply chain management. With blockchain technology, transactions can be documented in a permanent decentralized record and monitored securely and transparently. This can greatly reduce time delays and human mistakes. It can also be used to monitor costs, labor, and even waste and emissions at every point in the supply chain. This has serious implications for understanding and controlling the real environmental impact of products. The blockchain can also be used to verify the authenticity or fair trade status of products by tracking them from their origin. Some blockchain startups working in this sector are Provenance, Fluent, SkuChain, and BlockVerify.
Number 4, forecasting. Blockchain is set to change the entire approach to research, consulting, analysis, and forecasting. Online platforms like Augur are looking to create global decentralized prediction markets. These technologies can be used to place and monitor bets on anything from sports to stocks to elections in a decentralized way.
Number 5, networking and Internet of Things. Samsung and IBM are using blockchain technology for a new concept called Adept, which will create a decentralized network of IoT devices. Operating like a public ledger for a large number of devices, it would eliminate the need for a central location to handle communications between them. The devices would be able to communicate to each other directly to update software, manage bugs, and monitor energy usage.
Number 6, insurance. The global insurance market is based on trust management. Blockchain is a new way of managing trust and can be used to verify many types of data in insurance contracts, like the insured person's identity. So-called oracles can be used to integrate real-world data with blockchain smart contracts. This technology is very useful for any types of insurance that relies on real-world data, for example, crop insurance. Eternity is one blockchain project that is building tools that are useful in the insurance industry.
Number 7, private transport and ride sharing. The blockchain can be used to create decentralized versions of peer-to-peer ride-sharing apps, allowing both car owners and users to arrange terms and conditions in a secure way without third-party providers. Startups working in this area include Arcade City and Lazus. The use of built-in e-wallets can allow for car owners to automatically pay for parking, highway tolls, and electricity top-ups to their vehicle. UBS, ZF, and Energy are some of the startups developing blockchain-based e-wallets.
Number 8, cloud storage. Data on a centralized server is inherently vulnerable to hacking, data loss, or human error. Using blockchain technology allows cloud storage to be more secure and robust against attacks. Storage is one example of a cloud storage network using blockchain technology.
Number 9, charity. Common complaints in the charity space include inefficiency and corruption, which prevent money from reaching those who are meant for it. Using blockchain technology to track donations can let you be sure that your money is going to end up in the right hands. Bitcoin-based charities like BitGive Foundation use blockchain's secure and transparent distributed ledger to let donors see that the intended parties receive the funds.
Number 10, voting. Probably one of the most important areas of society that blockchain will disrupt is voting. The 2016 US election is not the first time certain parties were accused of rigging election results. Blockchain technology can be used for voter registration and identity verification, and electronic vote counting to ensure that only legitimate votes are counted and no votes are changed or removed. Creating an immutable, publicly viewable ledger of recorded votes would be a massive step forward in making elections more fair and democratic. Democracy Earth and Follow My Vote are two startups aiming to disrupt democracy itself through creating blockchain-based online voting systems for governments.
Number 11, government. Government systems are often slow and opaque and prone to corruption. Implementing blockchain-based systems can significantly reduce bureaucracy and increase security, efficiency, and transparency of government operations. Dubai, for example, is aiming to put its government documents on the blockchain by 2020.
Number 12, public benefits. The public benefits system is another sector that suffers from slowness and bureaucracy. Blockchain technology can help assess, verify, and distribute welfare or unemployment benefits in a much more streamlined and secure way. GovCoin is a UK-based company that is helping the government to distribute public benefits using blockchain technology. The blockchain is also a good contender for implementing a basic income. Circles is a project working on developing a blockchain-based technology for implementing a universal basic income.
Number 13, healthcare. Another industry that relies on so many legacy systems and is ripe for disruption is healthcare. One of the challenges hospitals face is the lack of a secure platform to store and share data. They're also often victims of hacking because of outdated infrastructure. Blockchain technology can allow hospitals to safely store data like medical records and share it with the authorized professionals or patients. This will improve data security and can even help improve accuracy and speed of diagnosis. Gem and Tyrion are two startups that are working on disrupting the current healthcare data space.
Number 14, energy management. Energy management has been a highly centralized industry for a long time. Energy producers and users cannot buy it directly from each other and have to go through the public grid or trusted private intermediary. Transactive Grid is a startup using the Ethereum blockchain that allows customers to buy and sell energy directly from each other in a peer-to-peer way.
Number 15, online music. Several blockchain startups are coming up with ways for musicians to get paid directly from their fans without giving up large percentages of sales to platforms or record companies. Smart contracts can also be used to automatically solve licensing issues and better catalog songs with their respective creators. Mycelia and Ujo Music are two startups creating blockchain-based solutions in the music industry.
Number 16, retail. When you shop, you trust the retail system of the store or the marketplace. Decentralized blockchain-based retail utilities work differently. They connect buyers and sellers without a middleman and associated fees. Sorry, Amazon. In these cases, trust comes from smart contract systems, the security of exchanges, and built-in reputation management systems. Two startups disrupting the retail space are OpenBazaar and OB1.
Number 17, real estate. Some of the issues in buying and selling real estate are bureaucracy, lack of transparency, fraud, and mistakes in public records. Using blockchain technology can speed up transactions by reducing the need for paper-based record keeping. It can also help with tracking, verifying ownership, ensuring accuracy of documents, and transferring property deeds. Ubiquity is a blockchain-secured platform for real estate record keeping that is an alternative for legacy paper-based systems.
Number 18, crowdfunding. Crowdfunding has become a popular method of fundraising for new startups and projects in recent years. Crowdfunding platforms exist to create trust between project creators and supporters, but they also charge high fees. In blockchain-based crowdfunding, trust is created through smart contracts and online reputation systems, which removes the need for a middleman. New projects can raise funds by releasing their own tokens that represent value and can later be exchanged for products, services, or cash. Many blockchain projects have now raised millions of dollars through such token sales. Although it's still early days and the regulatory future of blockchain-based crowdfunding is uncertain, it's an area that holds a lot of promise.
Number 19, your industry. If your industry deals with data or transactions of any kind, it's likely a field that can be disrupted by blockchain technology. The space is wide open and the opportunities are many.
Did we miss anything? What are some other industries that blockchain is disrupting? Leader.
Right, so that was just a real sort of quick run through of the sorts of things people are thinking about. I mean, you'll see articles on blockchain all over, probably one of the most sort of talked about subjects. I think when you look through stuff like this, you get to think about why, whether it will continue, whether cryptocurrencies will survive, whether people will implement blockchain in the ways described here. Don't know, but it's certainly a very interesting group of technologies, certainly worth finding more about if you're interested. And that was really just a quick run through to try and give you a sort of more of an understanding of what people talk about when they talk about cryptocurrencies, blockchain. So hopefully that's helped. Sort of go through some of the basic areas. What is a blockchain? Why are people interested in it? What are the business applications of it? So hopefully that was useful.
Is it energy inefficiency? Like we've heard about like mining Bitcoin taking the same energy as
absolutely.
Is that going to be a limiting factor?
Well, so there are currencies that don't require mining, or rather,
free mining.
But there are currencies which have a different approach to mining of that sort. So normally the mining we've talked about is loads of people are competing to mine something because they get paid to do it, and that's expensive. It needs a lot of infrastructure, it needs a lot of people involved. So there are other currencies that don't work on that principle.
If you don't have mining, how do you maintain the integrity? Because the way it works, that it ensures that it is wallet is because the wallet data is basically because there are so many computers are basically checking it. But if there is no point of mining, people wouldn't really run computers.
There is a concept which is called as
Let me just run you through this 2-minute video then. I skipped it before because I'm aware that we've been going for quite some time. But have a look at this.
IOTA makes use of distributed ledgers. Unlike most cryptos, it does not use a blockchain. Instead, it uses a technology its developers call the tangle, which is based off of a mathematical concept known as directed acyclic graphs. This was a purposeful move from the developers, as within this design is what separates IOTA from every other cryptocurrency.
This is what I've invested
in.
in.
Within the design, we have the removal of miners without sacrificing decentralization. With the need for miners removed, so are the need for fees. Yes, IOTA is completely free to use. This is because everyone plays an equal role in the network. Anytime a transaction is made, the issuer must help authenticate to previous and random transactions. It uses a series of cryptographic algorithms along with many other sophisticated techniques to do this work. This work is done behind the scenes, on such a small scale that any device could manage it without effort. Ultimately, a network like this allows for two important features: microtransactions and speed. Microtransactions are transactions that can be worth fractions of cents, and cryptos like Bitcoin face many issues with this, largely due to the necessity of miners. In short, you couldn't purchase a coffee with most blockchain-based cryptos. Moving on, we have speed. In cryptocurrency, speed is measured by TPS, transactions per second. We covered this in our last video, IOTA by the numbers. We suggest checking that out if you haven't already. In simple terms, none of us want to be stuck waiting hours for a transaction. Ultimately, with IOTA, the more people that use the network, the faster it becomes. alleviating the issues blockchain-based cryptocurrencies face today. It is these two features that give rise to IOTA's purpose, which is to support and facilitate a machine-to-machine economy, and to be implemented as the underlying protocol behind the Internet of Things. Our goal of reaching 10,000 subscribers is well underway, and everyone at Everything Tangled needs...
So I don't profess to understand anything about, I think, the algorithms that they're talking about, but I have read a reasonable amount about this sort of currency and its blockchain equivalent, and it removes the need for miners and fees as described. You're going to have to go and, if you're interested, you're going to have to go and find out more about it. But as people sort of go through that, as they sort of develop the blockchain and have this idea of miners, people have sort of taken that further and said, well, actually, is there a different way of doing it? And some of these currencies, like IOTA...
That makes sense. So I make one transaction, I validate two.
Correct. It does, doesn't it? Yeah, that's where my money is currently invested. So, hey, obviously I can't give you financial advice. I think that's actually quite neat technology. Right, draw that to an end. Thank you very much for coming. Hopefully that was interesting. It's a fascinating world. Go away and find out more about it. So, thank you. I'll send out the list of videos so you can have a look and follow some of the links.